Look at this video for the setup that I will be using in this. There is a link in the text for this video. I have now set all the units to use AGC. This is the one with the preselector, and this is the one without the preselector, and this is the old 1.2 firmware with the 1633 version of SDR-SHAR. There is a desired frequency. I can switch that off. You can see it disappears. We can see the effect of the preselector here. There are many more problems here, but there are problems here also, and they are due to the in-band signals. What I can do here, I wait for a ugly situation again. It happens occasionally. Yes, here we have. So I changed the threshold. And I go in and change the threshold here as well. At some time where it looks to be a problem. And I can increase the antenna signal a bit here. And I can increase it even more, 10 dB more. So now AGC is certainly active. And we can't see the desired signal anymore because gain is turned down so much. But we have these undesired intermodulation products. So I go for manual gain control instead. And then the ugliness disappears, but the noise floor is very high. So I reduce, well, I can increase the, sorry, I had switched off. And I switch on the desired signal and you can actually see it. And we have this non-linearities, so I need to reduce gain even more. Maybe like that. And even more. But I don't see the desired signal anymore, but I think I got rid of the interference. So I will demonstrate in a more clear-cut way with the signal generators. I have two FM modulated signals, one here and another here, plus a carrier on the mirror image frequency, and then a weak carrier here where I listen. The 1.2 firmware with the 1633 software, it's very hard to see the desired signal because I had switched it off and I switch it on now. You can see it here. So interference is much stronger. And I don't think this is interesting in this further study, so I remove that and then we can look at the two which use the latest firmware and software, and the preselector makes no difference because the signal is limited to a close range around 7.2 megahertz. It looks like this on the spectrum analyzer. The strongest signal is at minus 27 dBm. The generators, this one, and this one, and this one, they are all set for the same power level, so it means that the power of all these signals should be minus 22 dBm or so. 3 times means 5 decibels. I can check that by setting the resolution bandwidth to 1 megahertz. And then look for the power. And it says 19 dBm. I don't know why. Maybe bandwidth 3 megahertz is also possible. Yes. And then the power is minus 18 dBm of all these signals together. Span 10 megahertz and marker minus 18 dBm for everything together. The signal looks like this in the time domain. 75 millivolts peak to peak. That means the peak power is minus 18 dBm. And this is into a 50 ohm load. The oscilloscope is set for that. This means that the spectrum analyzer actually shows the peak power and not the RMS power as I thought. So there is a detector option. I changed it from peak to SP. I don't know exactly what that is, but it looks more reasonable. I know the peak power is minus 18, so I expect minus 23 for the RMS. And probably there is not a true RMS detector in here, so it's approximate in some way. Well, that's the signal anyway. I look at the audio spectrum from this unit. It's here, and you can see the signal to noise ratio is about 5 dB worse than without these generators. I switch off them. And the sensitivity is now better than it was when I tested before without the AGC. Because I had those measurements with an attenuator of 12 dB. So already here, well, this is the previous setting. I can now increase the level of the generators by 10 dB. And we have the desired signal here. The noise floor is much higher, but we don't have this ugly intermodulation problems. But sensitivity is down quite a lot. So I can reduce. Well, here the signal suddenly is reasonably good, but I can switch off and then on again. And I do get back to the same situation. That's not always, no, not the same. Something that is better. There is a memory effect inside the firmware of the HF Plus. The AGC is very complicated. I can change the AGC threshold and make it high. That should make a difference occasionally. And it seems that it looks different, but it isn't better or worse. Now I turned on more signal and we have a really horrible situation. It looks like this. And I changed the AGC threshold, which obviously is much better. These parameters give the best dynamic range as I have found it. If I switch on the AGC here, I get a significant degradation. Or maybe not, because looking here, the signal-to-noise ratio is actually about the same, although the noise floor is no longer white noise, it's the pattern from the generators. So probably this is not as good for practical purposes. If I turn down the level of the generators by 3 dB, then this is what I get with the AGC enabled. And if I disable it, the noise floor goes down and also the sensitivity by about 3 dB, because I have set a specific noise figure for the system. That means the same noise figure as I have on the pairshifts. I have set the level of the generators for about 2 dB loss of signal-to-noise ratio, and we can see here it's no longer a white noise background. There are these interferences from intermodulation products between the generators. Now I enable the AGC, and it's much worse. So in this case we are not so happy. The noise floor is very low, but the false signals are strong. So it depends on the situation. It could be an advantage, it could be a disadvantage. But now when I switch off the AGC, it's still the same, because there is a memory effect in the firmware. So to restore, I can stop and then restart. And you see, this doesn't help. I have to reduce the strong signals, like that, and then put them back. And even that doesn't work, so enable the AGC and remove the strong signals, disable the AGC and restart. And now it's okay again. So, once more. That was a very strong signal. And if I enable the AGC and add that very strong signal, it looks about the same. So remove and turn down again. You can hear the mirror image for a while until it is eliminated. So the AGC and memory effects that it has makes it hard to actually know what's going on inside the HF Plus. Note we have the same parameters here and here, but this one is significantly better than this one is significantly better than this one. And I can stop like that and then restart again. And unfortunately, some of the things are not remembered. So it seems that the unit isn't really reset. I have to remove the signal generators. Means I attenuate by 30 dB. Switch on the AGC and switch it off again. And then I go back 30 dB. And now it's okay. And I'm not sure what happened here. I will enable the AGC, turn down 30 dB, and then disable it, and then go back. And now it's much better. So it seems the recipe is, if you want dynamic range, disconnect the antenna, enable AGC, and then disable AGC, and then connect the antenna back. If you need more than 12 dB attenuation, it is better to add an external attenuator in front of the HF Plus. Remember that the noise figure of the HF Plus is very low. So it's and the dynamic range is very high, so it's not so likely that you need the attenuator, but it could be worth trying if you have a difficult environment.